Hi everyone, I'm Jeremy Faluti from TU Delft, and I do sustainable design tools and methods. And this is the total cost of ownership score for repair and durability combined together. This is a video summary of the paper by this name at Electronics Goes Green 2024. First, I want to say I don't want to hate on existing scorecards. I'm going to be talking about all of the problems with them in this talk, but I do want to begin by appreciating them. They are very important, and it's a very complex problem to try to deal with. So I do appreciate all of the scorecards that we have today. I just think that we can also make them even better. So how can we make them better? The motivation here is things like you can see the scorecards of these two different phones here. One of them gets a 4.5 out of 10, one of them gets a 9 out of 10. These are qualitative scores from, checklists of did you do this, did you do that? And as a consumer or purchaser, you look at these scores, how much better is a 9 out of 10 than a 4.5 out of 10? Is it twice as good? Is it 10% better? 10 times better? What does it actually mean for the product life? And then the other question is, does anybody care? Unfortunately, there's a decades-long trend of eco labels on products not making a difference in consumer purchasing behavior. And so how can we get people to change their behavior? How can we have a labeling system that does really motivate purchases? And then there's the question of durability versus repair. Some companies fight against repair scorecards because they say, well, our product doesn't need to be very repairable because it never breaks. And sometimes that's true. Sometimes it's bullshit. How do you know the difference? Well, let's measure it. And then finally, legislation in these kinds of scorecards is very slow and expensive because it's a qualitative checklist of did you do this, did you do that? Those checklists need to be very different for a smartphone than a television, than a washing machine or a vacuum cleaner, much less clothing or furniture. And so the process of scaling up repair scorecards for all product categories is very slow and expensive because you have to make them custom for every product. So what is the total cost of ownership score? It calculates the economic cost over time of a product. It shows the purchase cost, the retail price per lifetime, and the average repair costs with average failure rates. So that's this whole chunk here. And that's further broken down into cost of labor for those repairs, cost of spare parts or materials, and the cost of failing to repair, which means buying a new product. And the graph here is all in euros per year, and the blurs represent the uncertainty because there will always be uncertainty. Just because there's a lot of variation in component lifetime, product lifetime, even if we had perfect data, and we definitely will not have perfect data. So that will introduce more uncertainties, especially when there are new products first coming out, where we're basing these scores on previous lifetimes of previous components in previous products. So it's really important to capture the uncertainty. But as we'll see, you can still make good decisions with large uncertainties. And even if you don't like the numbers in euros per year, you can also have that translated into a qualitative scorecard, A, B, C, etc. And you may or may not actually publish the euros per year costs on the product label. Maybe you'll just have the qualitative score. And we'll talk more about that as well. But so how do you calculate this thing? Well, it is the sum of all the repairs and maintenance that you might do on a product. So for a phone, There's maybe the camera module needs replacing, maybe the display breaks when you drop the phone and, the cost to replace it. Maybe this is the likelihood of that getting replaced. And it'll depend. So the cost of each individual failure, it's by the failure. Did you drop it? Did it fall in the water? Did the battery wear out over time, etc.? The cost of the spare parts and materials. Maybe there's multiple spare parts or multiple materials that all goes in here. And then the time it takes to do the repair multiplied by the cost of labor in euros per hour. And then the cost of anything else, all the other stuff, maybe amortized tools, administration, overhead, etc. So that's the cost for each individual failure. But what if you can't do that repair? What if there's no user manual to explain the repair? What if spare parts are not available? Anything that causes that repair to fail is going to cost you, it's going to cause you to buy a new product. So this is the cost of buying a new product. And then the likelihood of that happening is inverse to the probability of the successful repair. So here's the probability of repair success for failure I, and then 1 minus that probability times the cost of the new product. That is the cost of not repairing it. And then you add up all of the expected repairs over the product's lifetime. So you get the thing that we had from the previous slide, and then you just multiply that by the probability of each failure mode, I, and you add that up for all the different failure modes. And then the total cost of ownership per year is that sum divided by the expected lifetime of the product, so that it's now in euros per year. And you add the cost of buying the product in the first place, divided by the expected lifetime. And so if there are no repairs, because the product never breaks, then the total cost of ownership will just be the purchase price divided by the lifetime. But the more repairs or maintenance you need to do, the more this term will increase. And so for an iPhone 12 Pro Max, and this was done 2 or 3 years ago, took us a while to get around to publishing, but at the time, for the data that we were able to gather, and a lot of the data that we could gather on cost of spare parts and likelihoods of different components failing came from iFixit. So we thank them very much for that data. Of course, there's still very large uncertainties here and things that we had to guess about. So there are pretty large blurs. And this is the same graph that we showed before. But basically, you can see that the retail price of the phone divided by the expected lifetime is 250 to 350 euros per year, roughly. And then here's the cost of labor for the expected repairs, the cost of parts, and the cost of not being able to repair, and all of those add up to the total repair costs per lifetime. And then that plus the purchase price per lifetime is the total cost of ownership. Now, interesting things you can see, despite the very large uncertainties, like labor here is plus minus 50% at least, but despite that large uncertainty, you can see that it is a lower cost than the cost of parts, and that even despite the uncertainties there, those costs are definitely lower than the cost to fail to repair. So that means that this particular product just needed more spare parts availability or better repair manuals or other things like that. Maybe there's software parts pairing, other things that get in the way of repairs. So that's it for the graph. And then for the label, we can say for each product category, for maybe for mobile phones, maybe the particular repair costs per year that we got there, are pretty bad, and so we'll call that a D. But maybe if it were a television, the same cost per year would be a great score. Or maybe if it's a washing machine, this would be a very bad score. This is the only thing that changes between product categories. All the equations, all this graph is the same exact methodology for any product, whether it's furniture or clothing or electronics or automobiles, anything. This is the only thing that changes, is the thresholds of what counts as a good score. So how do you do this scoring? Well, we just have an Excel spreadsheet, which granted is pretty tedious. There is a lot of data to enter, but it's pretty straightforward. And it has a few different steps to it that you can see very small across the top. It's too small to read there. So here's a blown up version of the part where you fill in the repair scorecard, the repair costs. So the cost of to repair the display, cost to repair the back cover, to replace the battery, etc. And we turn that into best case and worst case scores from all the different sources that you entered. And at the end, it generates the graph for you and it generates the qualitative label for you. So how do I think this will help? Well, first, it measures durability and repair on the same scale. So again, people argue about maybe durability is more important than repairability, because if it never breaks, then you never need to fix it. It doesn't matter whether it's repairable or not. And the problem is that argument will never end. It's Plato versus Aristotle arguing philosophy. Let's stop being philosophers and start being scientists. Let's measure the data here and make evidence-based decisions, because it's going to vary from product to product, from component to component, which one is more important. So we're starting to have durability labels, but it's a separate label. And so how do you compare them? You can't just make an overall score that's 50% durability and 50% repairability. That's arbitrary. It's not science-based. Let's make evidence-based decisions on where our priorities should go. Okay, and the next way that the total cost of ownership score will help is because it's quantitative rather than qualitative, and it's listed in euros per year, which are units that everybody understands and that very much motivate purchasing decisions, not just for consumers, but also for companies, for governments. Many institutions actually have rules about how much you're allowed to spend for different products. And making it transparent what the cost of ownership over time is enables companies or individuals to buy a product that might be more expensive up front, but will be more durable and thus cost them less money over time. And it's the other advantage of the quantitativeness is that it displays the uncertainty for subjective aspects or aspects that vary. And really the most important thing is that it eliminates judgment calls on weighing. So with traditional scorecards, the weighing is a big aspect of it. So maybe 10% is the availability of manuals, maybe 20% is disassembly time, maybe another 10% is the cost of spare parts, etc. All of those are subjective judgment values, and we eliminate all of that subjectivity by counting everything in euros per hour, or sorry, euros per year. And it also eliminates all the judgment calls on bundling. For example, the Fairphone 2 had a module that was just the camera, so you replace that one thing. The Fairphone 5, the same module, has 3 different cameras in it, and it, I think, also has the Wi-Fi module, other things. And so is this better or is it worse than this? People argue about that all the time today, but again, it's a Plato versus Aristotle philosophical argument. There is no first principles answer to that. It's going to vary from product to product, from component to component. The only way that you can make that decision in an evidence-based way is by actually running the numbers and measuring it. And then finally, I think the total cost of ownership score will help because it'll enable better legislation. First, in fast scaling, because it's exactly the same method for all product categories, whether it's smartphones or clothing or furniture. The only thing that varies, like I showed before, is that qualitative scorecard. Do you get an A or a B or a C? And it's less arbitrary and subjective. So again, one of the reasons that companies argue against having legislation at all on this stuff is because of the subjectivity, how much you can argue with the judgment calls they made in the scorecard. And this eliminates most of that subjectivity. And it also shows the uncertainty, how much things can vary, best case, worst case. And then finally, it enables innovation in industry. So with the current scorecards, they're checklists, like I say, and so to get a good score, you have to design your product the way that the checklist says. And so companies argue against that as well. They say it stifles innovation, but total cost of ownership lets you do whatever you want as long as you can show that it works in an evidence-based way. So let's see how this looks on the ground in a case study. So if we compare four mobile phones, and let's start off by saying a conservative estimate of 1.5 to 2 year lifespan, which is sort of an average here in the Netherlands a couple of years ago when we first did this. So here we have a Pixel, a Galaxy, an iPhone, and a Fairphone, and you can see the exact models in the paper. But here is how they score in the French Repairability Index, and here's how they score in iFixit. And you can immediately see that these two scorecards disagree a lot. I mean, they have similar scores for the Pixel and iPhone, but the Fairphone scores much better in iFixit than in FRI. And it doesn't change any conclusions. It's still the best in both, but it's barely the best here. And by here, it's the best by a huge amount. And more importantly, the Galaxy phone here scores very well. It's better than the Pixel and iPhone, but here it's much worse than the Pixel and iPhone. So this is conflicting advice. Which one is correct? What do you do with this information? Whereas the total cost of ownership, the costs that you get here, both the total costs, the light blue bars, and the sum of all repair costs, the dark blue bars, first of all, you can see that there is a lot of uncertainty in here. And so you can see that the Pixel and Galaxy, it's not clear which one is more expensive to repair. And so that might be the solution to what's happening here. Maybe the subjective judgment calls fall out one way in this scorecard and one way in this other scorecard, but this shows you the possible range. And so it shows you there's not a clear answer here. And then some things there are a clear answer for, by the way, like the iPhone definitely has the highest repair score and the highest total cost of ownership. And you can quantitatively say that its total cost of ownership is roughly double the Galaxy, roughly 3 times the Pixel. So that is a much more concrete thing than to say this one gets a 6 rather than a 3, or this one gets a 10 rather than a 6. And the Fairphone total cost of ownership is, the total cost of ownership might be similar to the Pixel, but the cost of repair is much lower. And again, we can be quantitative about that. We can say it's about a quarter the cost of the Pixel and Galaxy, about 1/5 the cost of the iPhone. So again, it's a quantitative comparison and it's in units that motivate people, money. And then if we look at the actual phone lifespans, We know that a few years ago, the iPhone lasted 4 to 5 years, not 2 years, and the Fairphone lasted 5 to 6 years. And so if we look at the FRI and iFixit scores, they don't change at all. The iPhone score is exactly the same, Fairphone score is exactly the same. That's because these only measure repairability. They don't measure durability. But of course, isn't the whole point of repairability to prolong the life of the phone? Shouldn't we measure how well it works? So the total cost of ownership does measure how well the repairs extend the life of the phone and how well the design for durability extends the life as well. So now the total cost of ownership of the iPhone goes from being by far the most expensive to being on par with the best in the previous measurement. And the Fairphone, of course, is by far the lowest cost of ownership of anything there. It's about a third the cost of the Pixel, and the repair costs are even lower. So again, I think that this will be motivating to purchasers. And even with the high uncertainties, there's a very clear winner here. And let's do some more sensitivity analysis. What if we're looking at the same phone designed differently? So here's the iPhone requiring professional repair. This is the same numbers that we saw earlier, but here's a theoretical scenario where the iPhone is completely self-repairable. So let's say the cost of labor goes to zero, you can see that there, and the likelihood of success is much higher, so the cost of failed repairs goes way down. So that doesn't change the purchase price at all. That's the same here and here, but it does greatly change the cost of repair and thus changes the total cost of ownership. And so that is in the bottom score here. There's also different scenarios that we ran. That's also in the paper. I won't get into them here for the sake of time. But one thing that we can see is that depending on these different scenarios for the iPhone, there are still significantly different outcomes, even beyond the uncertainty that we did calculate. So we really need better data on this stuff, on what the real failure rates are, what the real expected lifetimes are, uh, and so on. So to conclude, there are a bunch of advantages that I think the total cost of ownership score has. It integrates durability and repair on the same scale so that we can stop arguing philosophy and start making evidence-based decisions on when one is better than the other and when they can work together. And then it's a quantitative metric in euros per year, which are units that everyone understands, and that actually motivates purchasers, both consumers and professional or government purchasers. So I think it'll have a big edge over most eco labels, which don't change user behavior. And it'll be better for legislation because it scales fast and easily to any product category. It's the same methodology. The only thing that changes is that ABC score, and it's much more objective, and it enables innovation rather than being a list of prescriptive rules. And there are disadvantages, though. Like I said at the end, we need more data on failure rates and repair costs, etc. Um, we can generate this data, and a lot of companies already have this data. It's just not public, and it doesn't need to be made public. We just need the scoring to be done, and then the scores can become public, even if we don't publicize the numbers, even if we just publicize the A or B or C scores. So that is it. And I would love to make this a call for people to help out and participate. This is very much a work in progress. It's not ready for legislation yet. So if you are a company who wants to score your product on this, I'm happy to send you the calculator. You can email me here. And yeah, we very much hope that more people work on this to see if it really can be a better scorecard than what we have out there today. Thank you very much.